Let us now move on to item number 21. Solve for x in 2x plus 3 all over 3 equals x minus 3 all over 4. Is it 21 fifths, negative 21 fifths, negative 21 sevenths, or 9/4? Please give this problem a try, and if ready, I will divulge the answer in 3, 2, and 1. So from here, we could employ what we call multiplication property of equality, and that we will multiply both sides by the LCD of 3 and 4, which is 12. Or what others do is that they do what we call cross multiplication. So that is, the product of 2x plus 3 and 4 is equal to the product of 3 and x minus 3. And for such, we have this now. 4 times 2x plus 3 distributing 4 gives you 4 times 2x, that's 8x. 4 times 3, that's plus 12. Distributing the 3 here will give you 3 times x, 3x. 3 times negative 3, which is negative 9. And subtracting both sides by 3x and subtracting both sides by 12 as well gives us 5x equals negative 21. Dividing both sides by 5 gives you x equals negative 21 fifths, which is letter B. Next number. Which of the following is the simplified form of 2x plus 8 all over 8x minus 8 multiplied by x squared minus 1 times x squared plus 5x plus 4? So to do this, it is important that we know the concept of multiplication. That is, if you multiply two rational expressions, we multiply the numerator to numerator and denominator to denominator. However, if there are common factors between numerator and denominator, we may actually divide them and simplify whenever possible. So in this case, we will employ factoring. The 2x plus 8 is factorable as 2 quantity x plus 4. 8x minus 8 by taking out GCF of 8, so you have 8 times a quantity x minus 1. X squared minus 1 is a difference of 2 squares. And this is factorable as x plus minus 1 times x plus 1. And the denominator x squared plus 5x plus 4 is factorable as x plus 1 times x plus 4. And now we could actually see that there are like factors in both numerator and denominator. I mean, for example, the x plus 4 here, you have x plus 4 of the other fraction. So you could actually divide them. That becomes 1. We also have x minus 1, right? And we also have x plus 1. And what is left here on this one is 1 over 1, or simply 1. Here it's 2/8. So 2/8 times 1 over 1 is simply 2/8. But 2/8 could still be simplified as 1/4. Hence, the correct answer here is letter B. 23. The following relations are functions except 1-to-1, many-to-1, or 1-to-many, or all of the above. Take note that there are only 3 relations: 1-to-1, many-to-1, and 1-to-many. And so that you will not be confused, those relations that end with 1 are the functions. The relation that does not end with, that ends with many, is not a function. So remember, 1-to-many is not a function. 1-to-1 and many-to-1 are functions. Letter C is the correct answer here. 24. Find the sum of 3 over x plus 4 and 7 all over x minus 3. So sum implies addition. So we have to add these two fractions. So from here, if we will add them, you could see that they have different denominators. So they are dissimilar fractions. And since they are dissimilar, we have to look for their LCD in this case. That's x plus 4 times x minus 3. And here, x plus 4 divided by x minus 3, x plus 4 times x minus 3 divided by x plus 4 is x minus 3. That's why that's multiplied to 3. You have here 3 quantity x minus 3. Plus, copy it here, 7. This denominator divided by x minus 3 is just x plus 4 times 7. That's why I have here 7 times x plus 4 on the other part. And simplifying them, 3 times x minus 3 is 3x minus 9. 7 times the quantity x plus 4 is 7x plus 28. And I just copied the denominator. Because in the choices, the denominators are in factored form. I could now combine like terms in the numerator. So 3x plus 7x, that's 10x. Negative 9 plus 28, it's plus 19. Hence, the correct answer is 10x plus 19 all over the product of x plus 4 and x minus 3, letter B. All right. 25. What is the sum of the first 8 terms of the series 4 plus 20 plus 100 plus 500 plus and so on? First 8 terms only. So which of these do you think is the correct answer? You could actually see that to get the next term, you multiply by 5. 4 times 5, 20. 20 times 5, 100. 100 times 5, 500, and so on. So this is a geometric series. In this case, we're going to look for S sub 8, or the sum of the first 8 terms of this geometric series, with the first term equal to 4, because that's the first number there. And the common ratio is 5, because you're multiplying 5 all throughout to get the succeeding terms. And the formula for a sum of a geometric series, of your geometric series, is S sub n equals a sub 1 times r to the n minus 1 all over r minus 1, where the common ratio should not be equal to 1. So our n here will be 8 because we're looking for the sum of the first 8 terms. By substitution, we have S sub 8 equals the first term 4 times the quantity common ratio 5 raised to 8 minus 1 all over 5 minus 1. And you see that the 5 minus 1 here simplifies to 4. And 4 divided by 4 is 1. That's why what remains is 5 raised to 8 minus 1. And that is 390,624. 5 raised to 8 means 5 times 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 5. You are taking 5 as a factor 8 times. And that's 390,625 minus 1. That's why 390,624, or letter D for this case. Next one. Given the sequence 1, 3, 9, 27, and so on, what will be the 7th term? Is it 625, 729, 891, or 900? You could see from here as well, no, that it is a geometric sequence now, because the first term is 1 and each succeeding term could be achieved by multiplying 3. So 3 here is our common ratio. 1 times 3, 3 times 3, 9, 9 times 3, 27, and so on. And to determine the nth term of a geometric sequence, we actually use the formula a sub n equals a sub 1 times r to the n minus 1. So n here should be 7 because look, we're looking for the 7th term, with a sub 1 equal to 1 and that r equals 3. By substitution, we have a sub 7 equals 1 times the quantity 3 raised to 7 minus 1. 7 minus 1 here is the exponent, okay, which is 6. So that becomes 3. 1 times 3 raised to 6, or simply 3 raised to 6, and that is 729, letter B. So far, so good. Let's move on to 27. What is the remainder when the polynomial function f of x equals 5x cubed minus 3x squared minus x is divided by x minus 4? Is it negative 125, 148, or 268? There are many ways of doing this. I will be giving you only the remainder theorem. The remainder theorem states that if you divide this polynomial by a linear binomial divisor, all you have to do is equate the linear binomial divisor to 0. So x minus 4 equals 0. That gives us the value of x, which is 4. And what will you do? You will evaluate this function here when x is 4. So we will be solving for f, replacing all x here with 4. That becomes f of 4 equals 5 times 4 cubed minus 3 times 4 squared minus 4. The first one here simplifies to 320. 3 times 4 squared, that's 3 times 16 or 48 and minus 4. And this simplifies to 268. It should be letter D in this case. All right. Now, let's move on to the next item, which is 28. Which of the following is the factored form of 14x squared plus 23x plus 3? So which of these do you think? So what others do is, of course, they multiplied. And whichever gives you the product of 14x squared plus 23x plus 3, then that is the correct set of factors. Now, for our case, if you are just keen enough, no, we could see that if you multiply 7x plus 1 and 2x plus 3, 7x times 2x, that's 14x squared. 7x times 3, it's plus 21x. 1 times 2x, it's plus 2x. 1 times 3 is 3. You could combine 21x plus 2x, and that gives you 14x squared plus 23x plus 3, which is the desired expression in our given, and that's letter C. 29. Simplify x plus 3 times x squared plus 9 times x minus 3. So we will just get the product of this. And when you multiply them, which of these will be the correct product? Let's see. So in my case, I prefer to multiply the x plus 3 and x minus 3 because I'm sure that this is a sum and difference of two terms. Their answer will be a difference of two squares. And x plus 3 times x minus 3 will be x squared, then 3 squared, 9, then minus in between. So the product of x plus 3 and x minus 3 is x squared minus 9 times the x squared plus 9. It's still a difference of two squares. And using a similar reasoning, we arrive to x to the fourth minus 81, which is letter B. Number 30. What should be multiplied to x minus y to make x cubed minus y cubed? Which of these two expressions do you think should we multiply? Is it A, B, C, or D? To answer that question, it's important that we recall our identities. That is, x cubed plus y cubed is equal to x plus y times the quantity x squared minus xy plus y squared, whereas x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. If it's plus, plus, and minus here. If it's minus here, minus, minus, plus. The rest are the same. That's why you should multiply x minus y with x squared plus y squared plus, x squared. You should multiply x minus y with x squared plus xy plus y squared to get x cubed minus y cubed. and that is letter B.